So here we are, we've got the ladder. It's 13 feet long. And it's sliding away at 3 feet per second. And we want to know at what rate when it's 12 feet away. So when this is 12, that's going to be 5. Pythagorean identity. We have Pythagorean triple, 5, 12, 13. All right, so now, a couple things first off. We need to figure out, okay, here's my angle between the ladder and the ground. So what trig function do y'all want to use for this? Cosine, all right? So we're going to go with the cosine of theta equals, again, I'm going to call this x over L. And L is constant, so I can have 13 times the cosine of theta equals to x. So now I want to take the derivative of that. What is the derivative of the cosine of an angle as far as a related rate problem is concerned? Negative sine, so I get negative 13 times the sine of theta times d theta over dt equals what over here? Be careful. What's the derivative of x in a related rate problem? Yeah, dx dt. All right. So now we get negative 13. All right, what is the sine of this angle? Well, the sine of this angle is 5 over 13. And then d theta dt is what we're trying to solve for. And dx dt is what here? Is it positive or negative? It's positive because that side, as the ladder slides away, that length is getting bigger. So it's going to equal to positive 3 here. So your 13s cancel out, so you've got negative 5 d theta dt equals 3. So d theta dt is going to equal to negative 3/5. And again, remember this is in terms of radians, so technically does not have units. So it's negative 3/5 per second. So that is the change in that angle. Now, if we had used sine here, I want to use sine here to solve it. It would have worked out a little bit more difficult. You definitely picked the quickest way to work this problem. If I've got sine of theta, and I'll go ahead and put the 13 in the front. So 13 times the sine of theta would equal to y. So 13 times the cosine of theta, d theta dt equals dy dt. So cosine here is 12 over 13. So I've got 13 times 12 over 13 d theta dt. Now dy dt here, we don't know. And in most problems, we're going to solve for that dy dt before we solve for the angle missing, but let's go ahead and do this real quick. So x squared plus y squared equals, and typically I'll put L squared here, but again, we know in this problem, we've worked enough of these problems to know that this is constant, so we'll just say 13 squared. So 2x dx dt plus 2y dy dt equals 0. dy dt is what we're solving for. So 2y dy dt equals negative 2x dx dt. Divide out by 2. So we get y, which is 5, times dy dt, which is again what we're solving for, equals negative x being 12 here, so negative 12 times dx dt, and dx dt is positive 3. So we get dy dt equals, this is negative 36 over 5. Are we okay here? So dy dt here would be negative 36 over 5. All right, the 13s cancel out here. So we get d theta dt equals negative 36 over 5 times 12. And of course, 12 goes into 36 3 times. So we still get negative 3/5 here, which is exactly what we got over here when we use cosine. So whichever way you choose to work it, you should get the same answer. Probably if I'd already gone ahead and solved for dy dt, what I probably would have done at that point would have been to go with it. I just prefer taking the derivative of sine over cosine. It's nothing really different. It's just, that's normally my inclination to do.